Good morning, students. In the previous video session, yesterday's session, we have discussed about the properties of vector product or cross product. And today we are going to discuss about distance and displacement. You all know that from our smaller grade, we are studying about the distance and displacement. In smaller grade like grade 8, 9, 10 and all, you have discussed about this distance. Now let us see what is the difference between this distance and displacement. Let us consider 2 point, okay? Here one point and this point is A. Here another point, this point is B. Assume that one object is there at this point A. This is the object, okay? Or you can tell that here one object I kept. Now this object you can take from here and keep it here. This is what we can tell that displacement. The same thing, if you want to reach from the point B to A, sometimes we choose this way. Like this, we will reach at this point A. And this is what we are saying, distance. It means the actual path length traveled by an object in the given interval of time during the motion. You see, for this object to move from this point to the point A, so the actual path length, you see, this is a path length. So this path length traveled by an object, assume that this is object, this object is moving through this path for in a given interval of time. Within some time, this object is moved from the point B to A through this path, along this path. And this is what we are saying, distance and displacement. What I said, this is the initial position and this is the final position. From this initial position, you see, so there is a difference between this initial position and this final position. This difference between final position and initial position only we are saying what are displacement. So let us see the definition. So what is meant by distance and displacement? You can take a screenshot of this and study. You see, distance is the actual length path traveled by an object in the given interval of time during the motion. It is a positive scalar quantity. Always what we will get a positive value. And displacement, it is the difference between the final and initial position of the object in a given interval of time. Also, you can define as what the shortest distance between these two positions of the object and its direction from the initial position to the final position of the object during the given interval of time. So that is what I said. So from this point I am coming this point. So this is the shortest distance. This is the shortest distance I can reach from this initial point for this object to reach from this initial point to final point. And this is what we can tell. So from this initial point to final point, this object choose a shortest distance in a given interval of time. So that is what we are saying, displacement. And you see, from this point it choose another path So this total path length traveled by the object in a given interval of time, we are saying distance. So I believe that you understand the difference between this displacement and the distance. And here you can see an important example. An athlete covers 3 rounds on a circular track of radius 50 meter. Calculate the total distance and displacement traveled by him. It is an important question. You can go through this. So we know that question is, an athlete covers 3 rounds on a circular track. On this circular track, this athlete complete 3 rounds, and each round is 50 meter. So we know that this distance is equal to what? This distance is equal to the circumference, isn't it? So the total distance athlete covered, this distance is circular distance is equal to circumference of the circle 2 pi r. So that formula only here we are choosing. So we can choose the formula to find out that distance 2 pi r. And we know that 2 pi into r value. Each radius is 50 meter. So that and this is for 1 round, but these athletes cover 3 rounds, so into 3. So you can get what? 5 into 2, 6. So 50 into 5 into 3 is what? 5 into 3 is 15. So 150 into 2, 300. So 300 pi. So this 300 pi unit is meter, and you can find out the distance, approximate distance, by substituting the value 300 into what? 3.14. So I will get approximately 942 meter. This is one important 2-mark problem, so you can go through that. Okay, now the next part is displacement vector. So displacement vector, or you can tell that position vector. So assume that one particle, 2 particle P1 and P2 is there. So this particle moves from this point to the point P1, and another particle moves from this point to the point P2. And between this P1 and P2 there is a difference. There is a difference. So this is a position vector R1. So you see particle moving P1, position vector is R1. Another particle moving P2, position vector R2. And difference between this position is what? R2 minus R1. R2 minus R1. This difference is equal to, we can write delta R. So this is what? Position vector. Delta R vector is equal to R2 vector minus R1 vector. This is what a position vector formula. And here you can see one example is given. Note example. Considering R1 equal to x1 I unit vector plus y1 j unit vector plus z1 k unit vector, and R2 is equal to x2 I unit vector plus y2 j unit vector plus z2 k unit vector. Now if you are taking position, if you are finding the position vector delta r, you know that r2 minus r1 vector. So that r2 minus r1. So x2 minus x1. Here I. So you can find out this x1 I unit vector plus y1 j unit vector plus z1 k unit vector minus x2 I unit vector plus y2 j unit vector plus z2 k unit vector. If you are taking the difference, I is common, so you can write what here 2, here 1, because r2 minus r1, isn't it? So I is common, so x2 minus, here all becomes what minus, so x2 minus x1 I unit vector plus then what y2 minus y1 j unit vector plus z2 minus z1 k unit vector. This is how we can find out the position vector. You can take a screenshot of this and study. And the next thing is, based on this calculation, you can solve example 2.17, the same format only. Just find the difference between two vector. Okay, so go through that. That is also an important question. So you see, r1 is equal to I plus j, r2 is equal to what 4i minus 2j, 4i plus 2j. If you are finding the difference, 4i plus 2j minus I, here minus j, isn't it? Yes. So 4 minus what will come? 4 minus, here nothing is there, so 1 is there, 1 I unit vector. That is what this step. And plus 2, here also 1 is there, 2 minus 1 j unit vector. So 4 minus 1 is 3i, 2 minus 1 is 1. So that is what j. And finding the magnitude of this, magnitude means what? Only we have to square this. Here 3 is there, here 1 is there. So 3 square plus 1 square. So 3 square is 9, 1 square is 1. So 9 plus 7 is 10, 10 unit. So go through this example also. Next thing is differential calculus. So you know, when we are talking about this differential calculus, next part is differential calculus and integral calculus. Differential calculus, you can take a differential and integral. Differential calculus and integral calculus. In physics, we will start this differential calculus and integral calculus. So we will solve some derivation. In some of the derivation, we use this integration and differentiation. This differential calculus we can tell differentiation, and integral calculus we can tell shortly integration. And both this differentiation and integration we use to solve some derivation. In some of the biggest derivation we use So here we can see some of the basic of these differential calculus and integral calculus. Let us see what is the use of this differential calculus and integral calculus. The first thing is you have to know any of the physical quantity. If you are saying about the differential calculus, if you are saying about differential calculus, any physical quantity, you know that in physics there are so many physical quantities. So all these physical quantities we can represent by a function in mathematics. So this differential calculus, already I told differentiation and integration in mathematics. It is a vast chapter. Vast means very big chapter we will study. But here we are studying about some of the basic of this differentiation only. And mainly it is based on mathematics. Assume that we know that we can take on quantity temperature. Okay. Let us take a quantity temperature. We know that this temperature is always not be constant, isn't it? Temperature should not be constant. We know that our surrounding temperature is always changing throughout the day. Suppose morning when we wake up, the temperature will be very less. Maybe in our place and all, you can see some nearby some 28 degree like that. On example only I am saying. After some 10 o'clock and all, you can see some maybe 30 degrees, some 12 o'clock. 12 o'clock you can see 30. So every time the temperature is changing. When time goes, the temperature on a day is changing. So you can see there is a change in temperature when time is changing. This quantity is what changing every time. Quantity means we know that temperature is a physical quantity, and this physical quantity is changing when the time is changing. Morning to afternoon, you know the temperature is increasing, then afternoon to evening, you know the temperature is decreasing. So every time the temperature is what changing. So this we are analyzing, this change in temperature we are analyzing. That is the use of this calculus. So what is the use of this calculus? Used to analyze the change of any quantity. It is a mathematical function. It is a mathematical function. It is a branch of mathematics, and we are using to analyze the change of any quantity. Temperature changes we are analyzing by using this calculus in the mathematics. Not only this temperature, every physical quantity like this we can. So here you can see the temperature is changing with time. No, isn't it? So this only we are writing T of T. What is the meaning of this? Means temperature as a function of time. Temperature as a function of time. Let us see some mathematical derivative form of this differential calculation. It is very important. You have to learn this formula. If you know this formula, you can work out all the derivation in physics. You see, I will show you. You have to take a screenshot of this function and its derivative form. In differential calculus, we are using this derivative form dy by dx. This dy by dx means it represents the derivative of y with respect to x. What I said before, T of T, I am telling temperature as a function of time. Here dy by dx means we can tell what it is a derivative of y with respect to x. So let us see this formula. Actually, this differential calculus and all, it is a vast topic. We are taking only the basic part. So you, what I am saying, you study. Here you can study only this function and derivative form. It is very, very important. This is a basic formula we are using. N x power n minus 1. Note on this formula. It is very important formula. I will show you this. Y equal to x is the function. So its derivative form is dy by dx is equal to 1. How you got this one? While we solve this next one, we will understand. Okay. So y equal to x square. Y equal to x square means we can write a derivative form. Dy by dx form is 2x. Y equal to x square means its derivative form dy by dx is 2x. How you got this 2x? That is what here important, because our formula is n x power n minus 1. So our function is x square. X square, we are using this formula nx power n minus 1. This 2 is n. So this formula is x power n is equal to. Here you can note down this formula. X power n is equal to nx power n minus 1. So x power n is equal to nx power n minus 1. So x power 2 means 2x power 2 minus 1. So we will get 2x power 2 minus 1 is 1. So you can write y equal to x square is equal to, what you can write its derivative form dy by dx is equal to 2x. That is what second one. Let us see the third one. Y equal to x cube. So dy by dx we can find out is equal to what we will get. What we will get in the formula, x power n is equal to nx power n minus 1. So that x cube means 3x power 3 minus 1. So that what we will get 3x square. That is what next one. So based on data, this is a formula y equal to x power n. So dy by dx derivative form is nx power n minus 1. So sin x, if the function is sin x, then derivative form is cos x. If the function is cos x, then the derivative form is minus sin s. Then constant like pi and all, pi refractive index, like this constant you can put 0. Suppose y equal to ab means you can write this derivative form first like this. You see, y equal to ab means derivative form you can write dy by dx. Here 2 function is there, remaining all one function. Here 2 function is there, so that you can write first a you keep it constant, then this b you differentiate db by dx, this format. The same, then b you keep constant, differentiate a with respect to x. This is the meaning. Differentiate b with respect to dx. Differentiate a with respect to x. So here two quantity we are using this formula. So my dear students, and this today's video session, it is very important. You have to go through this example 2.16 and example 2.17. Then very important is study these formulas, and remember this. You can take a screenshot of this and learn this. It is very important, useful for you, and all the derivation, physics derivation, we use these formulas. Thank you all. Bye bye. See you on next class.